Okay, problem 11.2. Consider Newton's method applied to a function f in C2. The algorithm is written in this way, as we know for Newton's method. This is the Hessian matrix of f at the point xk. Now, suppose the alpha k is obtained from a line search. Okay. So by line search, we mean that the alpha k is obtained by minimizing the line search function phi. And in this case, the algorithm wants to show that if whether algorithm is a member of the quasi-Newton's family. So remember, for quasi-Newton's method, we have this requirement of for the var is hk times delta gi is equal to delta xi for all the I less than k, right? So that's the requirement for a quasi-Newton's method. For a quadratic function only, okay, not necessarily true for general function, but for quadratic functions, those equations must hold for quasi-Newton's method. So for quadratic functions, we have this f equal to that. So the Hessian is simply just the Q matrix in there. So the HK in this case will be just the Q inverse, always. So that means we're always using the Q inverse here, and that's why we multiply the Q inverse to this delta gi. It must be also equal to the delta xi because of the relation between delta gi and the delta xi, right? For quadratic functions, the delta gi is always equal to Q times delta xi. So that's why we put the Q inverse on both sides, then you get this. Okay, so it's kind of trivial and within expectation that Newton's method is also quasi-Newton's method. Actually, it's not very, very interesting here because we have showed in class that for quadratic functions, if you can apply the Newton's method, then it will converge within one iteration. Okay, so it doesn't really meaningful to discuss if it is a quasi-Newton's method or not because it's just converged within one iteration. Okay, but anyway, we show that for quadratic functions, we definitely still have this, although you probably already converge within one iteration, but this still holds. This still holds.